Hello everyone. In this video of CoppeliaSim, I want to show you two things. One, how to monitor a force sensor, how to get the values from a force sensor, and the other one, talking briefly about the layers. So let's first start with the layers. In the past, remember that whenever we clicked on anything, let's say this floor, right? If I double click on this floor, you see that under object, there is camera visibility layers, and from these 16 check marks or 16 bits, one of them is on. And it's in the bottom row here. Or for instance, if you go to the robot, then you see that it's this bit here. Okay, so each one of these objects for their visibility, even the graph, look at the graph, it has nothing here because I made it hidden. Originally, the graph had something like this. When you add a graph, right? Look, when you add a graph does have a visibility to it. You can see that here, right? Let me add another one so you can see better. So if I go and say add a graph, okay, look, this is the new one, this new graph. Let me move it so you can see it better. So look, you see? So the graphs are visible, but if you want, you can always go to their visibility and turn them off like this, okay? You see, now it goes to the hidden layers. So that is what you have with any object. You can make them visible or invisible, right? And the same thing goes for the sensor. The same thing goes for anything. For instance, here, I have the force sensor here, this green one, right? But if I want, I can go and make that one also invisible. All you need is to go here to this connection and go here, and you see this check mark, you can just make it off. Look, it's gone now. You see, it's not there. If I bring it back, there we go. And you see each one of them is in a separate place. For instance, look at this force sensor. It's this bit number 3 or 4, depending on how you call it. If this is 0, that's bit 3. And if you look at the proximity sensor, that's interesting. You see it's the exact same bit. So that means the sensors in CoppeliaSim, their visibility is this specific bit. But you see that the model, the robot, is this bit here, okay? So each category of objects for their visibility, they have a specific bit, right? And you have a default camera, right? Under default lights, if you open it, there are 4 lights. Where are they? I don't see them. How do I know they are invisible? Besides, of course, you cannot see them, is if you look, these items are gray. These items are black. If something is black, that's visible. If something is gray, that's invisible. But another thing you can do is to click on this icon here called layers. If you click on it, you're going to get this window. And right now, the top bits, the row 1, 8 bits, are for visible objects. So anything that is visible has one of these 8 bits on. And anything that goes to the bottom row, these are the invisible ones. So if I use invert, look what happens. Anything that was invisible is now visible. You might say like what? There we go. Look here. Look at these guys. These are what? These are your light sources. You see that? So these light sources that were hidden, now they are visible. Okay, anything that I made invisible should now be visible, right? And I can go back here and say, hey, hide those and bring these guys in. And look again. So you see that the texture of this floor is a visible layer, right? But the geometry of it, this part here, this block, that is the invisible part. You put the texture to make it visible and cover that. So basically, that's what I wanted to say. Each object has some visibility, and it has a bit according to the way that the software allocated to them. So you saw that bit 3 was a sensor, bit 1 was a model, and so on and so forth. And the other properties of this parts, including detectable, measurable, respondable, all of those, they also have some kind of bits too. They are all 16 bits. But here, what I wanted to show you was necessarily the visibility layers, okay? So that's one thing I wanted to show you. Now, the next thing that is the major focus for me is this force sensor. So here we have this force sensor, and despite you might think it only gives me a force like X force or Y or Z, it actually is a 6-axis. Not only it gives you Fx, Fy, Fz, it also gives you Tx, Ty, and Tz, with T is the torque or the moment. So that gives you 6 values, not just 3. And here I'm gonna read the values for that sensor, which it's caused by the motion between the caster and the body. And I'm going to plot all of those 6 in a graph for you. So the graph is here, and this is the script for it. I am gonna share this script with you, but it's very simple. So I'm gonna use the get object handle, and I get the handle from the connection, which is my force sensor here, and the graph. Then I use this command add graph stream, and to the graph handle, I'm gonna go and say call one of them fx. The unit is Newton, and basically the color is gray. The next one, the color is green or blue, orange, and so on. So you give them the RGB values, and then you create placeholders or handles for these curves. Now in your sensing, you're going to use your read force sensor. This is your main function. You pass to it the sensor, which is the force sensor. It gives you res, f, and t. Res is if it reads something. So it's a logical value. If it's positive, means you read something. F are the 3 fx, fy, fz, and t's are the 3 torques, tx, ty, tz. So you see I get their 1, 2, 3 components. And once I get those values, I'm gonna pass them to the graph and to the curve that is called fx, fy, fz. So I get those values and use this command set graph stream value. So I create the handles, then I pass the numbers to the stream values. It sets those numbers into those graphs, and then you say, hey, go to handle graph and get the simulation time. And so you need to put the simulation time also, and that's all it is. So now look, if I run this, look what you see. There we go. So the robot started moving. This is the same as my previous video. It is going to go until proximity sensor detects something, a specific range, then moves a little bit back and turn counterclockwise and keeps repeating and navigating. And you see that here I have all of these 6 values. Now it adds 3 extra things that I don't have, and they're all red. But these 3 graphs don't exist. But by default, when you use a force sensor, it always adds the magnitude. And because this is really a XY graph, it also adds XY dummy. So these 3 curves, as you see, they do not even exist. It's just the default of Coppelia. And you can modify your code trying to get rid of these, but I don't care too much about it. I want to show you the forces. So the green curve is Fy, the gray curve is Fx, the blue one is Fz, and then orange, cyan, and magenta are basically Tx, Ty, and Tz. And for instance, you see that your Fz value is almost at about 20 Newton. Where does that come from? So here the whole mg, if you do a simple static analysis, the whole mg and then 3 N forces on the wheels and the caster, the portion that goes to the caster, that is this normal force. But now that's not constant because the robot has jerky motion. And look, when it goes and hits the obstacle and moves back and the motion changes, this is where you see these numbers start to change. Okay, so these oscillations in the numbers correspond to when it is basically moving forward and backward. And that is where you see that some of the components start to change. So this is how basically you communicate with the sensor, and you can read the values. And not only that, if you want to make a decision now based on these numbers, not this one, based on these numbers, you can do that. So you can read it and say, for instance, if F1, which is Fx, is bigger than so much, stop the simulation. If F2 is bigger than so much, stop the simulation. So once you have access to these numbers for F and T from the read force sensor, you can do all sorts of logic in the navigation script of the robot here. Right now, the robot does its work. It has nothing to do with the force sensor. I'm just plotting it, but if you want, you can copy and paste this code into the script of the robot and do all sorts of logic. So hopefully this video was useful to you. You learned two important things in CoppeliaSim, and I'll see you in the next lecture. Thank you.